So today we shall finish the discussion on remaining part of resonance in general AC circuits. Some preliminary things which were taught with DC, same how can be applied to AC as well. Some remaining part of dependent source and current source. So that we will finish today, and from tomorrow very crucial part of stability based on transfer function, that will continue in remaining 2 weeks. So I presume that much material was uploaded on the group. When your mid-sem was over, some material was uploaded on the group. It is expected that you must have gone through it, but if not gone through, then again go through. Accept this request, something can't be done anymore now, that the things take their own course. So idea is now very clear, is that a circuit which consists of either inductor or capacitor, when subjected to an AC source, it results into a very peculiar behavior, that AC source is sinusoidal. Therefore, we have multiple options of finding out the answer, either by classical solution of differential equation, number one, or by assuming that the solution is of the type sinusoidal of same frequency, or considering impedance to be j omega L for inductor and 1 upon j omega C, or minus j upon omega C for capacitor. So I hope that the ideas are quite clear now. Is it okay? So any circuit which consists of AC source, we can solve using this. Then all our Kirchhoff's law, Thevenin's theorem, Norton's theorem, superposition theorem, everywhere what we have considered? Voltage sources we have considered. We have considered voltage sources, right? Constant voltage sources we consider, and we said that these are DC sources. Instead of that, we can also have AC source. And when it is AC source, the value of impedance, we say, for example, we can say that, and there is one more method of this is a resistor, this is a capacitor, this is an inductor. For a sinusoidal AC circuit, there is one important term, means each of them is expressed by such a small rectangular block as an impedance, means it can be anything. It can be anything. So its impedance, if I put as 10 ohm or even ohm, is presumed. Unit is ohm. Unit of impedance is ohm. Unit of impedance is ohm. So if I put, say, 10, it is resistor. So then in general it is having Z. Z is a term which is impedance, which can be purely real for resistor, which can be purely imaginary either for capacitor or for inductor, or which can be a complex, which is a combination of either resistor and inductor, or resistor and capacitor, or resistor and inductor and capacitor. So in general, a term is impedance Z. So it is 10. Then if it is in some other case J50. What J50 it corresponds to? It is a inductive component whose impedance is J50, means at given, means value of L need not be given. At given omega, impedance is J50, or impedance is minus J20. It's a capacitive impedance. Or you can have R plus L, you can say as 3 plus J4. 3 plus J4. Is it clear? So for voltage sources to be sinusoidal at the operating frequency, resistor behaves and exhibits the same resistance throughout the frequency range, whereas inductor and capacitor exhibit different impedance at different frequency. So if inductor is given, value L is given, you must need to know omega. Otherwise, for a given omega, directly such value can be given, you can work with this value. Is it clear? So impedance is a term which is like resistance but can be real, can be imaginary, can be complex. Is it all right? So some questions like, say for example, all the questions in the first module based on superposition theorem, based on Thevenin's theorem, means if a question is asked, find out Thevenin's equivalent circuit between A and B. How will you find out? Find out Thevenin's equivalent circuit between A and B. So, how can you proceed? So this is something, see now, as the available time is short, what we will do is we will not spend unnecessary time in computational things. Here, what is Thevenin's voltage? How you can find it out? Open circuit voltage means directly you can apply Kirchhoff's law. You can apply Kirchhoff's law, or straight away you can apply Kirchhoff's law. You can find IT by, or how, see this is this is a very interesting thing where it's not that we have solved this, but using common sense you must be able to solve. Using common sense you must be able to solve. Right? If you are able to solve using common sense, because there is no rocket science, there is new theme which has remained to be discussed. Only thing is that we have not discussed this problem earlier, this type of problem earlier, but all the necessary things to deal with this problem are already covered. So what I would like to suggest is that you do it today. If you find problem, we will elaborate it tomorrow. Is it right? So all these things similarly. Next, that is Z parameters. There is two-port network parameters. In that case also, what we have discussed, in all two-port network parameters, we have discussed only 1 dash, 2 dash. All resistive network we have considered. Now, when we think of using it for AC, instead of resistor, there can be resistor plus capacitor or inductor, only inductor, all kinds of impedances are there. So these are not resistance values, these are impedances. These are impedances. So instead of resistor, we may have resistor, we may have resistor plus capacitor, we may have inductor. Only thing is that the impedance value is given in terms of A plus JB. So when we have got A plus, and remember this is at given frequency of operation. For given frequency source, this is the value of the impedance. If frequency changes, the value will change. So the parameters are given as A plus Z. A plus Z are the in general impedance parameter. This is as regards to two-port network parameters. Then there is one more thing which changes, that is, so I will not elaborate, I will ask the question. Maximum power transfer theorem. So what was the theorem? We had not discussed it in the class because it was very simple. Already the videos were given and I hope those are self-explanatory because you have solved them properly. Actually solving maximum power transfer theorem properly is not something which is worth today. Let we should be very much clear that maybe 5 decades back, solving these things was a great achievement. Now it is presumed that you must know all these things. We have to move ahead. So what is maximum power transfer theorem? Can anybody repeat, elaborate or state? What is maximum power transfer theorem? Means what we are having, when the power is transferred from source to load, maximum power gets transferred when RL equal to RS, right? So we are having means whenever we say any real voltage source, any real practical voltage source, it has to have some kind of internal resistance. That also discussion we met when very less number of students were present. So this is Vs, this is Rs, and these are the terminals accessible. And here I connect RL, right? RL. So maximum power gets transferred when RL equal to Rs. This is for DC source. Now AC is also in much application. We are having AC mains, we can have transformer, we can get at the transformer center, again AC voltage source. So instead of DC, if I have got AC source, then this is AC source. Vs of we can say what it has to be. When it is AC source, it must be A sin omega t. A sin omega t is AC source. Then what this would be for AC source? Right. So you have how see he has either he has studied very huge, or he must have telepathic knowledge, or he must be having very good analytical ability. Then let the friends decide what can be the out of these three, what was the option. So instead of internal resistance now, for AC source, the concept is of internal impedance. Laksha laga. Now it is not RS, it is ZS. ZS. So it is resistor was real, whereas impedance is complex. When I say complex, it includes all the possibilities, either real or imaginary, either way positive, negative, or real plus imaginary in either way. Is it right? So ZS. And now, when we talk of load, power factor is some issue which was under consideration. Power factor correction circuits, all these things were there, but with now huge non-sinusoidal load, the issues related to electrical energy and power systems have got huge transformation. But it is now the load, that if we are having a motor load, electric motor, if we have got electric motor, it is what kind of load? Inductive load. So how many of you know that farmers who have come from farming sector, across the motor a capacitor is required to be put for correcting the power factor, and farmers normally don't put that. Why? Because for farmer, even if it is put or not put, it doesn't change any billing, because it is means if capacitor is not put, bill doesn't increase. So farmers are not so careful, but it changes power factor. If power factor is lagging as inductor, in that case, what we find? Anyway, I need to see that because of this kind of habit, we have get this what we can say huge divergence. So let us not go for that. In general, the theme is that we can have either an inductive load, or a capacitive load, or a resistive load, right? So the load resistance is not shown; it is load impedance, ZL. Now you state the maximum power transfer theorem for this case. Let us now see how effectively you can state. Restate the maximum power transfer theorem for AC load. So we can put a pause. Otherwise, those who are watching on the hardly anybody may watch, but